Hi, and today I'm looking at a simple home audio power amplifier circuit schematic. Now I was searching online for a simple power amplifier. I actually just typed in power amplifier and just see what would come up. And I came across this article which uses a complementary TIP142 and TIP147 Darlington pair transistors to form the basis of a power amplifier. And when we come down to the circuit diagram here, it's absolutely confusing. This makes absolutely no sense. Well, it does. It took me about probably a good minute to actually work out what was going on with this circuit. This is one output device. That's the other output device in a common emitter configuration here via these 2.33 ohm degeneration resistors. He's using 7 watt ones. Don't know why, 5 watt will suffice. And the power supply requirements are plus 45 and minus 45. And he's got two BC558 transistors here as the long tail pair, which I ended up working out. Yeah, that's a long tail pair because the emitters are now going through this 22k resistor to the positive rail. The audio comes in here. I'm not sure why this 10 microfarad capacitor has the positive going towards the base. It's neither here nor there, I guess. So it took me a while to figure out what was going on. Now with that current circuit, it's supposed to produce 150 watts into an 8 ohm load, which is it's debatable. I'll show you a completed redrawn schematic in just a second. So anyway, let's look at a redrawn schematic. Greetings, the Astro 30 here yet again, and as I said in the intro, I found a power amp online that was badly drawn and we couldn't actually see what the hell was going on. So I've redrawn the schematic out properly as it should be from left to right, long tail pair on the left, output stage on the right, and it's pretty simple. Now he used BC558 transistors here at the long tail pair. Now on a plus minus 45 volt power supply, that's getting really beyond the limits of the transistor chosen. So I've chosen BC556s here as a substitute. Over here we've got the TIP41C. I can get the TIP41C from JCar. I can also get its complementary TIP42C from JCar. There's no Miller compensation cap across the VAS stage here, which there should be. So this could go into oscillation quite easily. So that's why there's a dotted line here, because I'm probably going to stick a 100 puff capacitor across there. He had 1N4007 diodes across there. I've chosen 1N4004. There's not much in it. The 4007s are 1000 volt 1 amp, and the 4004s are 400 volt 1 amp. The output stage is formed by the TIP142 and the 147. I can't get these from JCar. I don't really want to order them and wait. So what I thought I might do is I can change this to a TIP41C and a TIP42C respectively, and Darlington into, say, a pair of TIP35 and 36C transistors to form my output stage. So we've still got a Darlington stage here, and yeah, there will be a finalised schematic at the end of this video, but is it changing the way this circuit would work? It's neither here nor there. As we can see, we've got this 10 microfarad capacitor going from the output, this is the output line here, back up here to the positive rail between this potential divider, and that's a form of bootstrapping, which it will increase the gain of the output stage and also improve its linearity. Other than that, it's a box standard amp. It should work. There's no reason why. So I'm just going to build it up with my changes and see how well the circuit performs with my changes. Should I actually be using these particular transistors? Yeah, probably, because we're testing a design on the internet. We don't know how well it works, if it'll even produce 150 watts. Now, I know discrete amplifiers pretty well, and even at plus minus 45 volt, we'd be lucky with this topology to get anywhere near 100 watt. Even if I end up with 40 or 50 watts out of this at plus 35 and minus 35 voltage rails is what I'm planning to do, will be excellent. Because I'm thinking I might actually stick that amplifier module in there. It's a simple amplifier, doesn't need any short circuit protection. Just a couple of fuses in the power supply rails, and yeah, easy peasy, Japanesey. Penis. Alright, so I've made my life a little bit easier for testing power amplifiers. I've taken this piece of L bracket aluminium, which is about 4 or 5 mil thick, I think it's 5 mil, and I've tapped and drilled 2 holes to M3 screws in it. It wasn't as hard as I thought it was. I used a drill tap. It's a tap that goes in the drill, and you just do it on a relatively slow speed and just drill through, and it'll pull itself through just nicely. Deburred it and everything, and yeah, I've now got 2 M3 threaded holes. Perfect for mounting transistors to it. And this would be the first time in the history of this channel that I've actually gone ahead and designed and routed the PCB before I've even tested the bloody circuit. So here it is, the power amplifier laid out. There's only a few subtle changes, like the addition of a 1K resistor here as a stopper resistor, a 470 picofarad capacitor here between the input and ground as a RFI filter, and there's the original 27K resistor that goes to ground. The other change I made is with the feedback resistor, which is here, is 27K instead of the 22. And instead of having the 220 ohm there, because the gain is way too high, that at 22K and 220 ohm, that's a gain of roughly 101. I've put this down now to a gain of 28 by making the 220 a 1K. The other two additions are the 2 fuses on the positive and negative, plus the 470 microfarad 63 volt capacitors on either rail going to ground. The drivers are mounted to the heatsink. These screw holes go to those little bracket things that I use, to little L bracket things, so I can actually mount the board at right angles to the heatsink to give this whole board structural rigidity, rather than just relying on the transistors to do the job. These 2 diodes are as close to these drivers as possible. The thing is, you'd want to make these touching these driver transistors with a little gloop of heatsink compound, just so the heat is transferred into the diodes to keep the biasing under control as the unit heats up. I've also reversed around the 10 microfarad input capacitor and put the positive to the actual input connection rather than having it going towards the base of the transistor. I can't see any reason why you would have the input going into the negative. It just doesn't make sense to me. You can always use a bipolar capacitor here if you wanted to, like a 10 microfarad 50 volt bipolar capacitor. This is the ground connection, which is actually a star connection. And by the way, if you can figure out who this anime sprite is, you win the internet. Anyway, if I zoom out a bit and then turn the board over, here's our ground connection here. As you can see, I've tried as best as possible to make all the ground points return back to this point in a star pattern, which is basic audio power amplifier design 101. So hopefully this won't cause any hum loops. It shouldn't if it's designed correctly. So there's the circuit board. So now I suppose we should lay the damn thing out on breadboard and see if the thing actually even works. That might be a good idea before going to the expense of making this PCB. And by the way, the PCB measures 100 millimeters wide by 50 millimeters long or deep. I'm not sure how much that's going to cost with PCB weight to manufacture. Probably not the $5 mark. That would be nice, but yeah. I think the boards need to be under 100 by 100 for that to happen. Anyhow, let's get on to actually testing whether or not the circuit works, so I can see whether or not I have to make any changes to my layout. Oh, okay, so this is what I mean about changing the input stage around. I've got 10 microfarad capacitor here with the positive going towards the input, 1K stopper resistor, 470 picofarad capacitor as an RF filter, and the 27K original resistor that was on here. This is part of the long tail pair. And for reference, with the output stage, I'm going for a TRP41C, TRP35C for the positive side. There's the 5-watt resistors, and a TRP42C and TIP36C respectively. So that's how I'm going to lay the circuit out on the breadboard in that configuration. Yes, it's changing it from the original premise of that, but I'm not going to go to the expense of buying these transistors and probably end up getting fakes off the internet from China. I'll just stick with known good transistors. If it produces 50 watts, which I'm hoping it will, at plus minus 35 volt, all well and good. Alright, let's get going. Alright, it's about 2 weeks later. I've got it constructed on the breadboard here. Haven't tested it yet, but here's our long tail pair input stage over here, a bass transistor up here, driver stage transistors up here. That's a bipolar 100 microfarad cap. I could not get an electrolytic because JK didn't have any. This is the output stage transistors with the generation resistors soldered across the terminals, and some heavy gauge hookup wire for the power connections. So as I said, I haven't tested it yet. I'm about to. Now if this doesn't work, it'll be a very short video. Anyway, I've got to set up some test equipment on a power supply. I'm only going to run it on 15015 in this video, not the full 35 plus minus voltage rails, because I can't really be bothered setting up a second transformer just to do it. Anyhow, on with testing, I suppose. I've got everything set up now. Oscilloscope, dummy load set to times 10, power supply. Now I've only got one clip lead left, which might make it a little bit awkward doing a sound test, but anyway, so I'll plug it in and see if we get an output. Hopefully we do. Well, can't see anything yet. That's up 4 and I'm not getting anything. I did check everything. Everything's wired correctly. Oh, we are getting a signal. It's very triangular, which is weird. That's with the frequency generator at 0. I think this is oscillating, because the waveform should not look like that. Make sure that nothing is getting hot. The drivers are warming up. Well, that's very interesting. I'm actually getting about 1.5 volt oscillation there. And I'm not 100% sure exactly why. So I'm going to have to fault find this. Well, now we're getting somewhere. I didn't have the input capacitor connected to the 1K resistor. It was off by a pin. But the output's jumping all over the place. That is probably a result of the fact that the bulk filtering capacitors aren't on this circuit board, which I probably should put on there. I haven't solved the oscillation problem yet, but that could be due to poor layout. But it is actually functioning. So, but I've got to go out now, so I'll come back a little bit later and fiddle with this a bit more. Bulk filtering did not cure the problem. I'm still getting around 6.1 volt peak to peak of oscillation there, and that's with the input connected to the computer. If I disconnect the input, it drops right off, but it's still oscillating. So I think there's something wrong with the input stage, because if I disconnect the base of the VAS from the collector of the long tail pair, the oscillation buggers off. So no, it's not the VAS or the output stage oscillating, it's the input stage by the looks of things. So what I'm going to do is I'm going to disconnect the negative feedback and the VAS out of circuit, and I'm going to measure what the actual input stage is doing. Okay, the other side of the long tail pair is connected via a 27k to ground. Feedback is removed, and funnily enough, there's no oscillation there. And if it is, it's very minute. But if I play a tone through it, we can see that we're getting an output. Albeit we can't see anything. I reckon it's 3 hertz going through there. It can't be. It's 1 kilohertz signal, not 3 hertz. So that's interesting. That's a bit better. I had the oscilloscope on the wrong time base. Must have been picking up the oscillation, but I'm getting 11 odd volt at the collector of the first transistor, which is about right, I suppose, for what's going in it. Now there's just one little issue. If I increase the amplitude of the look at that nasty ring. Okay, so I need to play with this a little bit more. Sometimes I'm a complete moron. This diode here, which is part of the biasing network, I had that cathode connected to the collector of the driver transistor, which is not where it goes. It goes to the base. So that was a complete and utter up. And now we have a much more stable looking output. Well, albeit it is moving around on the scope a bit, but that could be due to capacitance in the breadboard. But I am getting a healthy, I'm going to say 15 volt peak to peak before clipping. Now currently that's only pushing 7 watts into 8 ohms, which is not a big deal, is it? So I'm wondering if the circuit can be improved, like values of resistors. For instance, lowering that 1K5 that goes between the collector of the first transistor and the negative rail, just to lower the resistance a bit and see if we can get a little bit more oomph out the circuit there. And I believe that's as far as the output I can get out of it before clipping. Yeah, because it's starting to flat top and flat bottom at the 16 volt mark, so it is clipping. It's kind of dismal at this stage, but that was the reason why it was oscillating, is because the output stage was not turned on correctly. Right, now I do a little bit more fiddling and see if I can get this a little bit more powerful. It should be. I mean, I've got plus minus 20 volt going into the damn circuit. That's 40 volt DC. It should be producing more than 15 volt out. That's a problem. There's 16 volt DC offset on the output. Don't know why, but yeah, that's bad. That's unloaded and no input. Alright, I managed to get that DC offset down by using a variable resistor in place of the 3K3 resistor that goes to the positive of the capacitor on the bootstrap before the biasing network. So obviously that resistor was too low. So yeah, I've just set that variable resistor there. I don't know what the resistance is offhand at the moment. I'll find out a little bit later. I just want to find out, don't know why that's still warm. It hasn't been connected to the output for ages. But I just want to find out how that's affected the output signal. Bloody terrible. This is turning out to be a complete and utter nightmare at the moment. Well, I've changed the voltage divider network to a 22k and a 10k. Made it a little bit imbalanced just to reduce the DC offset on the output. I reckon it would work a lot better on a PCB, to be honest. And That 22k should be more like a 20k, but I don't have one. So yeah, it is what it is. I'm still getting a reasonable output. It doesn't look as sharp as I would like it to. Yeah, it looks very rounded at the top, but because the signal is jumping all over the place like that, it's really hard to tell. It's because of this freaking capacitance on bloody breadboards and shit. As I said in a previous video, breadboards do not make a good test bed for power amplifiers. Just saying. I reckon it'd work a lot better on the PCB. Well, I hope. I'll just change those two values of resistors. But what I'm going to do now is I'm just going to hook it up to a speaker and a source of music and bugger it. I'm done playing, messing around with it and getting nowhere, so I want to hear how it sounds. Okay, got the large speaker connected. Oh yeah, nope. Nope. Alright, so I'm giving this one a miss. I'm giving up on it because it is not functioning the way it was intended to function. Don't know why, since I connected the power up to the speaker, it's got mains noise through it. And when the power supply is disconnected, the positive rail LED turns out almost immediately, but the negative rail, it sits there glowing for ages and slowly discharges, and I don't know why. Okay, I've been messing around with this circuit for a while. I don't want to make this video too much longer. I've changed the output, well, driver transistors to a BD139, BD140. The VAS transistor is a BC546. I've configured the emitters of those two transistors tied together via two 100 ohms resistors. Back to the output point. The output stage is disconnected, but I've got the DC offsets down to minus 2.8 volt, which is still too high to connect a speaker. I'm using the AEL 480 power supply unit. The voltage I'm running into it's not high enough for that relay to pull in, but I'm not really worried about that at this point in time. All I want to do is get this circuit functioning correctly. So I've eliminated as many variables as I can. The output stage, buggered transistors. This is where I think I've experienced this problem before, where the input stage is not being balanced correctly. This is why we've got a large DC offset. And maybe if I mess with my negative feedback values here, and still keep it around about the 31 gain value, but change that to say 100k and a 3.3 or 4k7, whichever is closest to hand, just to see if raising the negative feedback resistor reduces the DC offset. So that's what I'm going to try now. Well, would you look at that? My sideways. What did I do? I messed around with the feedback components. That made no difference. I messed around with the values of the resistors here in the long tail pair, and then I changed the long tail pair transistors to BC558s instead of BC556s. For some reason the circuit will not operate with BC556s. Interesting. Well, with that in mind, that should be safe to connect up to a speaker. However, my output stage is not actually connected. So the next course of action is I'm going to reconnect the output stage and remove those 100 ohm resistors that are across the driver transistors, because I don't think they're needed, and we'll see if this actually works properly. Alright, output stage is connected, and we still have about 29 millivolt DC offset, which is perfectly acceptable. Probably going to be closer to 0 on a proper PCB. That's kind of annoying. That's the soldering iron. I'm wondering, maybe if I play with that 1K5 there and reduce that back to a 470 as I had before, that the DC offset may come down a little bit further. I'm going to try that first. The short answer to that is no. The DC offset came up to about 10 volt minus, so I'm leaving the circuit configuration alone. Alright, with my test equipment hooked up, let's see if we get a much more reasonable output voltage with no DC offset there skewing the results. Now, if we look at the scope there, we do have an output, but it does have a weird flat bottoming on the negative going cycle for some reason, but that's only when the volume is pretty low. We're still pushing out 7.5 volt peak to peak. So I'll wind the frequency output up and look at that. Nice, clean, stable waveform, and we're at 22.15 volt out, and that's still not maximum. So let me increase my laptop's output to 60%. Ignore that little bubble there, that was the stupid sound that the computer makes when you change the volume. Holy shit. We are pushing before clipping, I'm going to say 30 volt peak to peak. So I'll zero that out. That means we're pushing 28 watts peak at only a power supply rail of plus minus 20 thereabouts. So at the plus 35 minus 35 rails, I'm going to be saying we're going to be closer to the 45 watt mark, 50 watt mark peak. So far so good. Now I did change the bass transistor there to a BD139, but the DC offset went up to more like the 600 millivolt range. Not really excited about that. However, I want to actually know what the RMS value of that was. The RMS value is 9.9 volt. So more like the 12.2 watt range, RMS average value, which again is still not too bad. Now I'll change to a higher input. I want to make sure that I actually am clipping at the right time and that I'm not pushing more voltage out. That's at 100%. It's really hard to tell, but let's go up to 100% on the laptop. Yeah, nah, we're going to be the 30 volt mark, which is about right. So, because we were just clipping then. Okay, there are risks connecting up the speaker for the second time. Well, yeah, why not? Okay, got the speaker hooked up. Hopefully nothing goes wrong this time. Here we go. I'll be ready to quickly unplug. Okay, that was a weird turn on transient. Okay, that sounds kind of terrible. I don't know if that sounds better. Okay, hang on. It doesn't sound too bad. Those tweeters sound like shit. Okay, what I'm going to do is I'm going to fiddle with it a bit longer. That's what she said. Sounds a bit better. Alright, with a bit of experimentation I managed to get the DC offset with no input connected and no output connected around about minus 31 millivolt. I changed the 1K5 collector resistor for the first transistor to a 2K2, and that seems to have improved things. It doesn't sound as distorted as it was. It's just pretty much all about balancing the long tail pair input stage so that it functions correctly. It can take a bit of experimentation. As for the original design that the schematic came from, it probably does work in its current configuration, but I can't verify that because I don't have the right transistors. However, it took me a lot of messing about to get this to play nicely and function correctly without having humongous DC offset into the speaker, and this turns out to be these two input transistors, so the BC558s on the original schematic is correct. However, running it at plus minus 45 volt DC rail across those transistors, yeah, they're only rated for a CE or collector emitter voltage of I think it's 35 volt. So anyway, it is functioning and a lot better than it was yesterday. It's taken me 2 days of messing around to get this to work. Yeah. Anyway, so what I'll do is I'll go ahead and make the changes on the PCB. It just means I'll have to reverse the connections of the base and emitter connections on the drivers because they're a different pin out than the original transistors I designed it with, and change the resistor values that I've changed. I don't know if I mentioned before, I've been doing a lot this morning. The bootstrap potential divider is put back to the 3.3K and 3.3K resistors respectively. I probably did mention that, I just don't remember. So I don't think there's a turn off transient. I'll just wait. Well, I've been waiting a fair few seconds and I don't hear one. Oh, there it went. Just a little tiny pop. As for when you plug it in, there's that little bit of mains buzz, 100 Hz hum coming through. I reckon it would have to do with most likely the bootstrap capacitor. I've noticed on a lot of bootstrap amps that you get that kind of noise. Plus, the way that this is laid out is not ideal. Probably work a lot better on a PCB, and if everything was wired back to the power supply correctly and not just strewn all over the place, then yeah, it would be probably a lot better. So that's what I'm going to do. I'm going to make the changes on the PCB, have the PCB ordered, build the thing and hope the thing actually functions first time out the box without too much messing around. Anyway, I hope you enjoyed this video. I solved the problem. I'm the Astro 30, and if you did enjoy this video, please remember to rate, comment and subscribe below, and you can always follow me on Facebook, and you can become a Patreon supporter for as little as $1 a month. I'd like some more Patreons, guys. Anyway, this is the Astro 30 saying see ya. See you in the next one.